Hello everyone. So for our control system assignment, we have chosen to do regarding automatic glass door. So my name is DANISH MOHANA and my metric number is B08 1910149. And rest of you guys can introduce yourself.
Okay, my name is NISHANTHI SUBRAMANIAM. My matching number is B08191025.
And my name is NABIL ILMAN, and my metric number is B0819103339.
All right. So for our introduction, since we're doing about automatic glass door, so in the development of this era, more of the glass door are being developed in automatic and also manual. So in the real application, there will be two, which is one is automatic, and other one will be automatic and then manually control, which is using the controller. For the input, we are using it at angle which is 30, 60, 90, so that the angle of the door being open, we can measure it with the transfer function. Uh, that's all for the introduction. So this is the automatic glass door, which will be controlled by an arm, which will be placed over here. There will be an arm which controls the doors closing and opening. As for this is the transfer function for the automatic gate application. So there will be a desired input, which is in we are using in degree. For example, the 30 and 60 and 90. So that will be the input value of the step, and also this is the transfer function of the automatic glass door, and the output will be the opening and closing of the glass door. So next is we are using these are the command that we are using, and the clock voltage we are using is 10 decimal, stop time 0, initial time 0, sample time we are using 0.1, and then at the final value at this part we are changing the input value, which is for now we are using 30 for the next, and then the third graph we will be using 60 and 90. And this is the simulating diagram that we already construct, which consists of a step as input, and then a feedback, and then this will be the marks, which is the input that carries to the output of the multimeter, and then the oscilloscope. Sorry, and then this will be the remote and the clock, which is already we have set. So as for the output, we can refer our lab sheet. So these are the for the first one, which is using 30 degree as input, and this is the value that this is the graph that we obtain. So Nabil, can you explain about this?
Okay, so I will explain about the result graph for the simulation. Okay, this is the output graph for 30%. So as we can see from what we got from it, what we got from the graph is we got the peak value. The peak value for 30% is 34.21, and we got the TS is 0.3.
Right. So this is for the 30 degree input, and the next one this is for the 60.
Okay, so this is the output graph for Simulink at 60 degree, and we can see the peak value for 60 degree is 68.53, and the TS value is 0.299.
So another one is this is the time that you already settled with it. You already settled down. The value later we can refer the table. We already find out the value for the TR. This is the TP. This is the TS, and TR will be find it here, and then the settling time. The final value will be found here.
And for the third one and for the last graph, the output graph for the Simulink for 90 degree, we got the peak value at 102.8 for peak value, and the TS value is 0.3.
All right. So after we already refer this graph, which is we obtained by using doing the simulation in our MATLAB simulating circuit. For the table, which we are using 30 as input, so we obtain final value of 30, which is equal to 0 percentage of input and output, which is ESS is 0. And then the peak value that we obtain is 34.2. And also the one that Nabil already explained, which is the TP and also the TR value, ATS value. We already stated here. And for the 60, the input that we are giving is 60, and then the final value also being 60. And the peak value, it will be much more higher, which is 68.53. As also for the 90 degree, the final value will be 90 and the peak value will be much more higher, which is the door is at its 90-degree angle open. So that's all for the table, and this is the calculation one, which we can refer the calculated method we already shown in this step. And for this, we know that for this calculation, which is regarding the parabolic input and also the step and ramp, we already calculated it, and we since it's going the KP value of lim GS, which we get is infinity, and also for the KV for the GS2, which is 25.38. And then this is for the static error constant, and for this we already get the steady state error for each step, which is input, step input, ramp input, and parabolic. For step we got it as 0, which is the 30 angle that we're giving as input, and then the output also being exactly same. And then for the next one, for the RAM we get 0.04. And for the RAM, the graph will be exactly shooting upward, which will be the graph settling time, which is the final value will be going up. And then since it's going up, uh, we cannot measure the value of exact final value. So Nisha, can you explain about the conclusion that
Okay.
we get?
Okay, from this project, we have successfully contract a system for automatic glass door using the MATLAB software. So we also improve our knowledge to creating and coding the system, and we have learned the control subject. We really enjoy in this project. We also have gained some new information and experience in our study. So we hope that we learn this in this subject can give us a lot of an advantage that we can apply whether working environment or daily application in the future.
Alright.
Thank you.
So I think that's all for our presentation. So you guys have got anything to say?
No,
Abid?
That's all.
Alright.
thank you.
Thank you. I think that's all
Thank
for
you.
our
That's all from
presentation.
us.
Thank you.